Alright guys, so today we're going to look at linear models, which lines up with exercise 2G of your textbook. So up till now we've been looking at linear relationships, which is the relationship between x and y, which we've been looking at in equations. So this can be used in a number of different areas, kind of practical applications, which we're going to look at now through a couple of examples. So, first example, an internet provider charges a base fee of $30 per month. For every 1 gigabyte used, the company charges an extra $2. So a pretty ordinary deal for an internet provider. So part A wants us to construct a costs function that describes the internet bill. So let's let C equal total cost, and the other variable is G, gigabytes used. Okay, so how we would set this up? Pretty simple. So we're trying to find a cost function. So cost we know is equal to. So reading the question, it's good to underline as you're going. You know that even if they use no data whatsoever, there's going to be this fixed cost of $30. Okay, so we're going to put that back there because you know no matter what happens with how much gigabyte they use, they're going to use $30. We also know that for every gig used, so this is the variable, the company is going to charge an extra $2. So for every gigabyte used, they'll charge $2. So if 1 was used, the cost would be $30 plus 2 times by 1, so it would be $32. If 2 was used, it would be 2 times by 2, 4 plus 30, so it would be $34. So that is a cost function. No matter what the gigabyte is, how many gigabytes you use, you can find out exactly how much that will cost. So that's part A. Part B, part B here, so I'll just bring up the drawing tool, asks us to graph the function. And this is where you should definitely be using a ruler. It's a bit hard on this computer, but I'll have a go. So graphing the function, so in this case the y would be cost, because that's the independent variable, and gigabytes would be the x-axis. So from this we know what's the y-intercept would be. It would be 30 here, so we know it's starting, you can just pick any point here as long as you label it, 30, and then we know, graph this function by finding the cost when 20 gigabytes is used. So C would equal to 2 lots of 20 plus 30, which is equal to $70. Okay, so at 20 gig, so this is 20, and could make that 70 approximately here. And then using a rule, you'd link these two up because it's increasing at a fixed rate. So that would be 20 and 70. Okay, fantastic. Alright, so that's how you do that. Question 2. John leaves town on a bike travelling towards town B at a constant rate of 10 kilometers per hour. If town B is 85 kilometers from town A, describe the distance from town A in terms of t. So we're describing distance in terms of t. So d would be our independent variable, and we know distance from town A at the start would be 85 kilometers, and then for every hour he would travel 10 kilometers closer to town B. So 10 for every t. Okay? That's how you do that one. So we know that the constant, the 85 kilometers away at the start, then every hour, where t is equal to time in hours. So for every hour, he's coming 10 kilometers closer. And that's how you'd cover that. So exercise 2G, guys.